Hello and welcome back. In this tutorial, we will study integration. Before, we've been differentiating function. So we would have a given function and we would find derivative. Now, we will do the other way around. We would guess, basically, which function we have to differentiate in order to obtain particular function. Let's say we have function f of x, which is x to the power of 4 plus 3x squared minus 9. Let us guess which function we have to differentiate in order to obtain this particular function. Well, if we differentiate x to the power of 5, it will give me this power of 4 here, right? So derivative will give me 5x to the power of 4. But we need particular function here, x to the power of 4, without multiplier of 5. So basically, I have to differentiate 1 over 5, x to the power of 5, in order to cancel this multiplier. And I obtain x to the power of 4. To get 3x squared, I just have to differentiate function x cubed. And to obtain minus 9, I would differentiate just negative 9 times x. So basically, in order to find which function we have to differentiate in order to obtain this function f of x, we have to find the following function, capital F of x, which would be 1 over 5 x to the power of 5 plus x cubed minus 9 times x. This function called antiderivative of function f of x. So basically, the definition of antiderivative is the following. Given function f of x, any function capital F of x, such that derivative of this function is small f of x, is called antiderivative. We have special notation for this. In general, we have general integral of function f of x dx, which is equal to capital function f of x plus constant c. This notation is called integral. F of x is antiderivative, and c is just some constant. This multiplier d of x telling us over which variable we integrated. So right now, dx, it means that we integrating over variable x. So basically, integral and dx, they're always going together. It's like one formula, one function. In our notations now, we can write that integral of function f of x is equal to capital function f of x. So we can rewrite integral of x to the 4 plus 3x squared minus 9 dx is equal to, and here's our antiderivative, 1 over 5 x to the 5 plus x cubed minus 9x plus some constant c. Why we need this constant c here? Well, apparently, if you think about function capital F of x as this function, and if you add some constant c to it, look, derivative of this new function f of x will give me exactly the same result, x to the 4 plus 3x squared minus 9, just because derivative of the constant is equal to 0. This is called general antiderivative or general integral. Let us do some examples. For integration for general antiderivatives, we use some formulas. So integral of x to the power of n dx is equal to x to the power n plus 1 over n plus 1 plus constant c. Integral of e to the power of x dx is just exponential function itself plus constant c. Integral of 1 over x dx is just a logarithm of x plus constant c. And now we can also integrate the multiplication of function by constant and sum and difference of the functions. So we can write that integral of constant k times function f of x dx is the same as k times integral of f of x dx. So basically we just took this constant k outside of the integration, and integral of the sum and difference of two functions is just the sum and difference of the integrals. Let us practice now. Let us integrate the following function. X to the power of 4 plus x cubed minus 9 dx. I have sum and difference of three functions here, so I can split them as three integrals. So I have integral of x to the 4 dx plus integral of x cubed dx minus integral of 9 dx. Now I can pull constant outside of the integration. So we have this constant 9 here, which we can pull outside. We obtain integral of x to the 4 dx plus integral of x cubed dx minus 9 integral of dx. And now we start to integrate using our formulas. As you see, here we're mostly using formula 1 with different values of n. So first integral will give us n equal to 4. So the integral will give x to the power of 4 plus 1 divided by 4 plus 1. Second integral with n equal to 3. We have x to the 4 divided by 4 minus 9 times, and integral of dx is always equal to 1 times x. And now plus constant c for all of these integrals. So it's not necessarily to write plus constant c for each of the integral. It's enough to write one general constant c at the end of the integration. Let us integrate the following function. Integral of 4th root of x minus 3 over x plus 2 over square root of x dx. Again, by the properties of integration, I can rewrite this as three different integrals. So it will be equal to integral of x to the power 1 over 4. So root of 4 I'll represent as the rational power dx minus integral of 3 over x dx plus integral of 2 over x to the power half dx. Now we can bring outside all the multipliers. We have integral of x to the power 1 over 4 minus 3 integrals of 1 over x plus 2 integrals of x to the power of negative half dx, dx, dx. Now we just use formulas. X to the power of 1 over 4, this is the first formula with n equal to 1 over 4. It will give us x to the power 1 over 4 plus 1 over 1 over 4 plus 1. Minus 3 times integral of 1 over x, its specific formula, which is logarithm of x, plus 2 times, and again, our first formula with n equal to negative half. X to the power negative half plus 1 over negative half plus 1, and I add constant c at the end. Now it's your turn to practice.